Ми подивилися два відосики, що таке Service Mesh і Understanding Istio Features. І тепер ми подивимося на архітектуру Istio та кости Istio. Ну, давайте ось цей.
So we've seen how to deploy
Чути, чи звук є?
Так, чутно.
Добре.
Звуку немає, здається.
Він дуже швидко говорить, правильно?
Ні, не було чути, тому що...
Було чутно, а потім вмкнули ще раз і перестало.
Напевно, мікрофон вимкнули і через це не було чутно.
Давайте, добре, зараз я тоді перешарю. І я думаю, що все ж таки ми подивимося ось Installing Istio on Kubernetes with Docker Desktop, тому що я пропустила цю тему намірено, але мені здається, що я зараз це зробила. Зараз перешарю. Я перешарила.
We're going to get started with Istio. We're going to look at some basic prerequisites for running Istio in a non-production environment. We'll deploy Istio in the demo configuration.
Все гаразд зі звуком зараз?
Так, зараз добре.
Добре. Угу. Чи не швидко він говорить? Нормально?
В принципі, нормально.
Добре. Угу.
Which is pretty much the all-in configuration that gives you access to all the features so you can try them out. And we'll do that using Docker Desktop. So I've got Docker Desktop running here. You don't have to use Docker Desktop, but it does give you a Kubernetes deployment. So you can install Docker Desktop on Windows or Mac. If you're using Windows, switch to Linux containers, enable your Kubernetes cluster, and then you'll be ready to go. If you're not using Docker Desktop, you can use Docker Community Edition on Linux, and then you'll need your own Kubernetes environment. So you can run something like Minikube or Kind, Kubernetes in Docker. If you are using Docker Desktop, you need to make sure you've got enough memory available because Kubernetes with Istio and the sample application uses quite a lot of RAM. So under the Resources tab here, you'll need at least 5 gigabytes of memory allocated to your machine. And that's all the prereqs that you need. So all the demos that I'm going to go through are in the resources for the course. We're in the M2 folder for this module, and each of the demos has a README document that describes exactly the steps that I'm going to do so you can repeat this yourself. So I'm going to switch to the more attractive view and get rid of the Explorer and open up my terminal. So I've got Kubernetes running, but I've got nothing deployed at the moment. So this is an empty reset Kubernetes cluster. And I'm going to deploy Istio in 2 stages. So the first stage is to deploy the custom resource definitions. So this is why Istio works so nicely with Kubernetes. Kubernetes lets you define your own type of resources that get stored in the Kubernetes database and managed through the Kubernetes API. And these are all the resources that Istio manages. So later on in this module, we're going to be looking at virtual services. And the virtual service is defined here, along with a whole bunch of other resources. So we can close this down. And the first thing to do is just to apply my custom resources. So this just creates the resources that Istio is going to use. Istio is not actually running yet. These are just the components that Istio is going to use. So the next thing is to deploy Istio itself. Now, there are different ways of deploying Istio, but I wanted to show you a Kubernetes native way. So this YAML file here is just a standard Kubernetes deployment document with config maps, the secrets and services, all the things you usually expect, as well as using some of those custom resources that we've just created the definitions for. Now, if you go to the Istio website, there are different configurations of Istio that you can deploy. This is the demo configuration, which gives you a whole bunch of useful things like Grafana dashboards, tracing with Jaeger, all sorts of things like that. But the cost of all those features is that you have this 20,000 lines of YAML. Now, ordinarily, you wouldn't deploy using this sort of YAML file in a production environment. We'll cover that later in the course. But for a non-production environment where I want to see how all this stuff works, the demo configuration gives me access to all of Istio's features. So I deploy that in the usual way using kubectl.apply. It's going to deploy a bunch of services, a bunch of deployments. There are going to be replica sets. There are going to be jobs that run as part of the initial configuration of Istio. And when this is completed, I'm going to have a whole bunch of things that are running. So if I clear this down, if I repeat my getAll command, I've got nothing in the default namespace because Istio installs things into its own namespace. So if I want to see what's actually running here, I need to look inside the Istio system namespace. And then I'll see all the pieces that have just been deployed. So there are some batch jobs here that have already completed. I've got various replica sets. I've got deployments that are still spinning up. I've got services for all the various different components. And here I've got my pods. So all the components of Istio run as Docker containers. So when you run this for the first time, all these Docker images get pulled and all the components start up. So it'll take a little while for everything to be ready. And this is why you need to bump up the memory allocation on Docker Desktop, because all the various parts of Istio have memory requests, and you need to make sure you've got enough RAM for all the components to start up. So if I now have a look at the pods, you can just see that everything's up and running. That all looks good. So all the parts of Istio are running now. Now I have a service mesh that's running in my cluster, and now I could deploy my application and register those components with the service mesh. But Istio has this really nice feature for automatically registering components with the mesh based on labels in your namespace. So if I now create a label for my default namespace, so the label's called Istio injection equals enabled, and I'll just check my namespace to make sure it's there. And there it is. So what that basically means is now, as part of my deployment, Istio is integrated with Kubernetes, and it will get notifications anytime any new resources get created. If a new pod gets created, Istio will get a notification. It can go and look at the namespace for the pod, see if automatic injection is enabled, and if it is, it will create the proxy inside that pod without you having to manually register the component with the mesh. Okay, so my service mesh is up and running. Let me see what else is in my system. I've got no applications of my own, so I haven't deployed my demo app yet. I've just deployed Istio, which is in its own namespace. But if I look at the containers that are running, so everything is running in Docker containers, all the parts of Istio and all the parts of Kubernetes. And what I'll see is I've got 45 containers running, even though I'm not doing anything at all. So this is one of the themes that we'll come back to as we use Istio more and more, is that the service mesh is not free. There's a cost to running it, and there's an ongoing compute cost to having that service mesh take control of all your network communication. So right now, without running any applications of my own, I've got 45 containers that are using CPU and memory, but they're not powering any of my business applications. So now we've seen these things that are running, let's switch back to some slides and see what those components of Istio are actually doing. Istio, they're not going to use Istio at all. So service A will still talk directly to service B. Now, when I register those components with Istio, whether I do that through
Секундочку, воно було промотане. Я повернуся.
Seeing how to deploy Istio. There are different ways of doing it. There are Helm charts that you can use in a production environment, and Istio has its own command line tool that you can use. But if you want to get an understanding of what's happening under the covers, you can take a standard Kubernetes manifest and deploy it using kubectl.apply. So now I have Istio running. Let's see what it actually does. So here's a really simple distributed application. I've got service A that talks to service B. Now, I could deploy this app in my Kubernetes cluster, and my Kubernetes cluster already has Istio running. So all those components that I saw running in containers, those are powering the Istio control plane. And that control plane is broken into these three components that have different responsibilities: Pilot, Mixer, and Citadel. But until I register my services with Istio, they're not going to use Istio at all. So service A will still talk directly to service B. Now, when I register those components with Istio, whether I do that through automatic registration with the namespace label or whether I do it manually, when those services run, they're going to have a proxy running as a sidecar in that same pod. So my pod for service A has one container with the service in it and a second container with the proxy, and the same with service B. There's a container that's powering the service and a second container that's powering the proxy. And now all communication is going through the proxy components, and that's transparent to my application containers. So service A still makes the call to service B, but actually it gets routed through the proxy that's running as a sidecar in the service A pod, and it gets received by the proxy that's running as a sidecar in the service B pod. And now we can see where those components of Istio come in. So Pilot is the component that takes all the configuration that you save in Istio and it pushes it to the proxies. So the proxies all have the latest config for the mesh, and that's provided by Pilot. Citadel is all to do with security certificates. So it generates certificates for any new services that join the mesh, and it delivers certificates to the proxies when they need them. So each component that makes a call can present its client certificate to verify who it is, and each service that receives a call can present its server certificate so the communication between the two can be encrypted. But the bulk of the work that Istio does is in Mixer. Mixer is the runtime component. So every call that goes through the proxy is going to potentially make use of a feature from Mixer. Mixer applies policies and it collects telemetry. So in this diagram, when service A makes its call, the proxies might check with Mixer to confirm that service A is allowed to talk to service B, and then the proxies will send telemetry to Mixer saying what network call happened, how long it took, what the response code was, all sorts of information. So that can all be tracked and made available in the various dashboards that Istio supports. Now, Istio is pretty heavily optimized, so all things like the configuration data and the TLS certs, they're all cached as heavily as they can be, but Mixer can be quite an expensive component because potentially it gets called with every single network call. So Mixer can end up using a lot of CPU, and that brings us back to our point that there's a cost of using the service mesh. So there aren't a huge number of studies at the moment, but there's a really good write-up from Michael Kipper at Shopify, and this blog post is well worth reading. So they looked at using Istio for their main applications, they did a bunch of proof of concepts, and they deployed it to a production-like environment. And what they found was that the cost of running Istio, just the extra compute power to run the control plane, was going to cost them an extra $50,000 a month just to have the CPU and memory for all the features of Istio. Now, that was for a pretty high load service, and obviously your own mileage is going to vary with these things, but you do need to be aware that when you implement Istio, there's a lot of things under the covers. So all the projects that form part of the Istio architecture, they're all on GitHub, and they're all open source, and you can get a feel for how big these components are. So Istio itself comes in at just under 500,000 lines of code, but Istio uses Envoy as its proxy, and Envoy itself is 300,000. I'm running those on top of Kubernetes. Kubernetes is huge. There's nearly 3.5 million lines of code in the current code base. And then you need your container runtime, and I'm using Docker, and Docker itself comes in at just over 1 million. So you can run your .NET Core REST API that's just 10 lines of code, and you deploy it on top of Istio, and there are 5 million lines of code powering the platform underneath it. Now, lines of code is a naive way to say how big the project is, but I'm just showing you this so you understand there's an awful lot happening under the scenes. These are all different projects with different governance structures, their own release timescales, and their own worldwide development teams. So if you bring this into your architecture, you own all these components now. You need to own the management of them and the updates of them to be sure that when you deploy an update to Kubernetes, it's not going to destroy your Istio and vice versa. So if Istio requires you to have all this stuff and it costs so much to run, what do you actually get in return? Well, we're going to be using a really simple demo application for this course, which is the standard Istio book information demo app. You can find all the source code for this app on Istio's GitHub repo, but actually I've made a few modifications, so in the source for this project there are a few changes to some of those components. So you can walk through the demos in this course on your own, using the resources for each module, and if you go to the Istio website, there are a different set of tasks you can do using the same application, so you'll be working with a familiar context. And the Book Info app is just a really simple website that consumes different microservices. You can deploy it without Istio. When you deploy it with Istio, then all those components have a proxy injected and managed by Istio. And Istio also takes care of ingress. So external traffic coming into Kubernetes gets managed by Istio and then sent to the application homepage. We're going to use this simple app to demonstrate the main features of Istio, but tying them into real-world use cases. So I'll be showing you how to do staged deployments with blue-green deployments and canaries, all using Istio. I'll show you how security works with authentication and authorization between these components, and how we can add reliability at the network level without changing code, without deploying new versions of our application, just by changing the way these components talk to each other using Istio. So next, we're going to deploy this application and see how it looks. In this demo, we're going to
Чи є питання поки по тому, що ми слухаємо? В нас план прослухати цей модуль до кінця, ось саме з Istio. Тобто це наш план.
Deploy the simple Book Info demo application. We'll see the deployment definition just uses standard Kubernetes objects, services, and pods to run the application, and we'll also use a custom Istio component, an ingress gateway, to take the traffic from the outside world that comes into our cluster and bring it into our application. And then we'll run the app and see how it looks under Istio. Okay, so here's the README doc for this demo. The first thing I'm going to do is deploy my book info application using this Kubernetes manifest. Now, everything in here is a standard Kubernetes object. So the architecture that I've just shown you of the book info app, all those components are defined as standard Kubernetes objects. So the details microservice that gets you the information about each book, there's a Kubernetes service with a named port, there's a service account, so this component runs under a known identity, and then there's a deployment, which just specifies the Docker image that's going to run this application, the service account to use, and some labels that identify this as the details part of the application that's currently running version 1. We've got the same structure for all the components of the application. There's the ratings microservice that has a Kubernetes service, service account and deployment, and there's the same for the review service, and the product page, which is the entry point to the application. But that has the same structure, a service account, and a deployment. So if I open my terminal, and I'll start by deploying that application. This is a standard Kubernetes deployment. So it's going to create a service account, and a deployment for all my applications. And now if I look at the pods, I'll see these are all up and running. Okay. So at the moment, no traffic can get into my application. Now I could change the product page service so it used a node port or a load balancer and send traffic in that way. But as this is an Istio course, I'm going to let Istio manage the traffic into my application. And for that, I'm going to create a gateway. So a gateway is a custom Istio resource that listens for traffic coming into the cluster. And in this case, it's listening for HTTP traffic on the standard port 80, and this gateway will pick up any host name. So you can have different gateways listening for different protocols and different host domains. This definition picks up HTTP traffic for any host domain that's coming in on port 80. And the second object I have here is a virtual service. Again, this is another custom Istio resource, and we'll spend a lot more time looking at what a virtual service does over the next few modules. But at its simplest, all I'm doing here is I'm tying this service to my gateway. So any traffic that comes into the gateway that's HTTP for any host name, if there's a match for any of these request paths, I'm going to send the traffic into my product page service. So these two components, the gateway and the virtual service, are saying when traffic comes into my Kubernetes cluster for any HTTP host, if those paths match this list here, then they're going to get sent to the product page. So it's just a way of directing traffic into my application that comes into my cluster. Okay, so I deploy that in the same way. So even though these are custom resources, I'm still using kubectl apply, and that will create my gateway and my virtual service. I've seen the pods are already running for my application, so I will have a look at the ingress gateway. So this gateway is part of the Istio deployment, and this is what's actually receiving the traffic that comes into the cluster. This is a load balancer type of service with all these various ports that are mapped. Because I'm running on Docker desktop, my external IP is localhost, so I can send traffic into my localhost. It will get to my gateway and ultimately go through my virtual service into my product page application. So if I browse to my product page, this traffic's coming into my Kubernetes cluster, Istio is picking it up, applying the rules, and sending it to my application. So this is the demo application. It's really simple and basic. The top lines come from the product page itself. The book details come from my book details microservice. The book reviews on the right-hand side come from my reviews microservice. It's pretty basic and pretty simple. These are all Kubernetes components, but because I've deployed them to the default namespace, which has automatic Istio injection enabled, each of these components has a sidecar in the pod that's taking care of the network traffic, and that's my Istio proxy. And I can see all that just by navigating around my Kubernetes deployment. If I look at the pod for my product page, there's a whole bunch of information in here, but what I'll see when I scroll up to the containers is that there are two. There's one container for my application component, which is my book info product page image. And there's a second container for the proxy, which is the Istio proxy v2 image. So my application container is running in the same way as it would without Istio, but all the network traffic is going through my sidecar proxy, and that's what's applying the rules. So all these things are just Docker containers, and I'll see if I...
Звернули увагу, да, ось на те тільки що він показував. Ось ці два контейнери. Один з них сервіс, а інший з них сайдкар з всіма потрохами Istio.
The rules. So all these things are just Docker containers, and I'll see if I look at my container list that everything has a proxy. So all my components have got their own proxies. There's the product page, the ratings, the reviews. Everything has its own container sitting alongside the application container that's managing the network traffic. So I can grab the container ID for my product page proxy. And I can put that into my Docker container top command and see what's actually running. And there are two processes that are running inside this proxy. So this is the proxy container in the sidecar alongside my product page container in the pod. There are two processes that are running. There's Envoy itself, which is the actual proxy. So this is applying all the rules. Any traffic that comes out of my product page application container goes through Envoy, and Envoy applies the rules that I've set up. And then there's a Pilot agent that's also sat in that container. So this is the thing that connects to Pilot and gets the configuration updates from Istio. So when I make any changes to my network config through Istio, they get stored centrally in Pilot, and then all the Pilot agents running in all the sidecar proxies pick up the latest configuration. Okay, so that's my application running through Istio. It works in the same way as if I wasn't using Istio because I'm not applying any rules yet, but all that traffic is going through those proxies. So next, we'll take another look at that virtual service object and see what you can do with it. So we've seen how to deploy an application with Istio. It's the standard Kubernetes deployment process. The first thing I deployed was my book info application, which just used ordinary Kubernetes resources, services, service accounts, and deployments. And then I deployed some custom Istio objects to get the traffic from the outside world into my application. So the gateway and the virtual service, they're custom Istio resources, which we'll be exploring a lot more. But the way I deploy all this stuff is standard kubectl apply. So when you start using Istio, this fits really nicely with your current CI/CD pipelines because you define all your network rules in YAML files and you apply them to your cluster using kubectl apply. Right now, we're not doing anything particularly useful with Istio, but when we understand how Istio injects itself into the networking layer, then we can start to unlock some of the more advanced features. So firstly, let's have a look at this communication between the product page and the details API. So when I load my page, I get some information about the book, including the author and the publisher, and that comes from this details microservice. Now, at the highest level, these components just talk to each other directly. But when I'm deploying on Kubernetes, there's a lot of resources in between. So if I deploy without Istio, then my details component has a Kubernetes service, which links the hostname details to an IP address. That service acts as a load balancer across all the pods that I'm running, and Kubernetes will add or remove pods to the load balancer when I scale my application, or if any of those pods fail their readiness checks, and in each of those pods there's a container running my application. And that container will ultimately receive the request, action it, and send the response back to the caller. Now, when I deploy with Istio, I have the choice of creating a virtual service as well. So the Kubernetes service still lives in the background, and it gets used by Istio to find the pods underneath. But it doesn't get used in the communication. Instead, it's the virtual service that links that hostname details to an underlying pod. So this is an Istio custom resource. It lives inside the Kubernetes API, and the virtual service acts like a router. The configuration of the virtual service gets applied to the proxy, and the proxy enforces whatever rules you've set up inside the virtual service. So those rules get defined in a Kubernetes YAML file, like everything else, specifying that this is using the Istio API and this is a virtual service type of object. And the virtual service definition will specify the host. In this case, it's just the details host name, but it could be a fully qualified domain name or an IP address. And then you configure the routing rules for that host. So I can say any HTTP traffic that gets requested for that host, I'm actually going to route it to this destination. And in this case, I'm using my Kubernetes service. So I'm using the same details host names. So if I deploy this, this will just act like a pass-through and send the traffic to the same details pod, but through the Istio networking stack rather than the Kubernetes networking stack. But when I have my virtual service in place, that's when I can start applying some more rules and using some of the more advanced features of Istio. So this basic virtual service will just send the traffic to the details pod. But I could extend my virtual service to put some rules in there to do things like traffic shaping. So when the product page consumes the details service, actually 90% of the traffic goes to my V1 deployment and 10% goes to V2, and that's all configured within Istio, and it's completely transparent to the product page. This is how you do staged deployments using Istio. You just shape the traffic to different endpoints as you're doing your deployment. That lets you send a small amount of traffic to the version 2 details service in your production cluster, verify that everything's working as it should, and then gradually you change the percentages so that everything goes to V2 and no traffic goes to V1. Or you can use your virtual service for fault tolerance. So if I'm having problems with my details service, I can put a timeout into my virtual service configuration to say that if a client call takes longer than 10 seconds, we're not going to keep that connection open and carry on waiting for the service to reply. Instead, after 10 seconds, Istio will reply with an error saying that the service is not available. Or as a more advanced variation, if the service has intermittent failures, I can include retries in my virtual service definition to say that if a request fails with a certain known type of failure, then just immediately retry it. And that's transparent to the consumer. So the product page could send a request to the details service, that service errors, Istio catches the error, retries the request, this time it succeeds, and the product page gets the successful response. It doesn't even see the fact there was an error in between. Those sorts of features are really useful for getting fault tolerance in your application without having to manually write a bunch of that logic into your consumer code. And they can also be very useful to help you mitigate production problems when they occur, and we'll see that in the next demo. In this demo, we're going to see how you can use Istio to manage traffic between your application components without changing the applications themselves. We're going to add fault tolerance to our app and get a workaround for a bad release using client timeouts and then automatic retries. So here are the docs for this demo. The first thing we're going to do is deploy a virtual service. And this virtual service is identical to the one that I showed you in the slides. So all this is going to do is take any requests for the details hostname and send them to one of the pods from the Kubernetes service. But that traffic is going to be routed through Istio. Now when I apply this, it won't change how my application behaves. So if I have a look at that service, describe virtual service details. The specification shows me the host is details, the destination is details, and there are no kind of routing rules in between. So I'll browse back to my application, and it all works in the same way. The book details are coming from my microservice. They're now being routed through the virtual service configuration, but that configuration is just the same as the previous one, so everything works in the same way. Now I'm going to simulate a new release that causes a problem. So I'm going to update a release to the details service. Actually, all this does is it uses the same application image, but it sets this feature flag, which says the first time a user calls it, it's going to fail. So every time the connection gets made to this details service now, it's going to fail unless you repeat the call. So this is just a standard Kubernetes deployment. Let's clear this down. I'll apply my bad release. Okay, that looks good. I'm going to open up a new terminal and have a look at the logs for that details component. And that will tell me whether it's going to behave badly or properly. No logs right yet. If I browse back to my product page, the failure mode for this deployment is that the details service will time out after 30 seconds. So my product page is going to make a call to my details component, and after 30 seconds it times out and it shows me there's an error fetching the details. If I check the logs, we can see that it received a new request and it's going to time out. Okay, so right now our application is broken. The homepage still works, but any users that browse to it, there's a 30-second delay before the call to the details service times out. And obviously we don't want that. So we can use Istio to try and make that problem better. And the first thing I can do is put a timeout in there. So rather than waiting for 30 seconds, it only waits for 5 seconds. So if I have a look at this update to my virtual service, it's still linking the details host name to the pods under the details service, but I'm applying a timeout now of 5 seconds. I'm not changing my application code or my application configuration. All that stays the same. Now at the networking layer, Istio is going to monitor the calls that come into the details service, and if they take longer than 5 seconds, it's going to automatically time out and return an error to the client. So back to my command line, and let's apply that change to my virtual service. Have a look at that virtual service in there. So now my configuration links the details host to the details service, and the timeout is 5 seconds. So if I browse back to my product page and refresh, the same thing happens. I still see there's an error fetching the product details, but it comes back much more quickly. So the app is still not complete, but at least it fails in a way that means it's still usable. But we can go one step further than this. As we're mitigating this production issue, maybe we've got a development team who are looking into the problem, and they've told us that if the product page immediately does a retry for the same service request, then this time it will work. We don't want to change the product page app to do that retry logic. We can do that in Istio too. So I've got a new definition for my virtual service that has a retry in there. Now the retry configuration is a little bit more involved. So firstly, I'm saying I will automatically do 2 retries. If a call to the details service comes back with a response somewhere in the 500 range, so an HTTP failure, it will automatically retry. Now I've also specified a timeout connection for each retry, but that kind of gets overridden by the failure mode. So I'm saying I only want you to retry if there's a 500 error, so Istio is going to wait until it gets that 500 error before it does the retry. And effectively, this is a change to how my application consumes the service. but I deploy it just as an Istio change. So all I'm applying are my new virtual service configuration. And check the description. And now it has my retry configuration in there. I didn't change anything to do with the application or the configuration. And if I switch back to my log terminal, it's still the same pod that's running. My application container hasn't changed. My configuration hasn't changed. All that's changed is my proxy configuration. So now when I go back to my home page, I'm going to tile this with my log window. And now when I refresh, we'll see a log comes in for a new request and it's going to time out. The request ID is that long GUI that comes from the product page application. So it sends that as part of every request. Now that ID 744, Istio is now waiting to see if it gets a 500 response. So it will wait for the full 30 seconds. When it gets the 500 response from the details service, it will automatically retry because then that falls into the retry logic. And there we are. Without any trickery, I didn't press F5 very quietly or hit the refresh button or anything like that. Istio has repeated the request. I can see the same request ID, 744, comes through. This time the application responds correctly and my web page is working correctly. So my user experience is still not great. If I refresh, I still have to wait that 30 seconds, but I do get a working page when it comes back because Istio is automatically doing that retry for me. And there's my application working correctly, albeit slowly. So now we've seen the power of what Istio can do. I've changed how my application works without changing my application code or my application configuration. So we'll finish this module with a recap of what we've covered, and then we'll move on and spend a whole module looking at traffic management in more detail. So in this module, we've seen a bit of what Istio can do, and I hope that last demo really helped you understand the power of what a service mesh brings to your application. Registering your app with Istio brings all these proxies into play, and that allows you to centrally control the communication between the components of your app without deploying any changes to your app. So I've used my virtual service definition to make my app more fault tolerant. We saw how you can use Istio to time out at the network level rather than keeping your client waiting for an application to respond. And we saw how to do automatic retries. And just those simple Istio definitions can help you mitigate a production problem with a release while you have people working on the full fix. So let's summarize the module. Istio is a service mesh, and that's really a control plane for the communication between your application components. It runs on different platforms, but it works really nicely with Kubernetes because Kubernetes has all these integration points that let you hook logic into the Kubernetes API. And we've seen you can deploy Istio running as containers in your Kubernetes cluster and configure your namespaces to automatically inject the Istio network proxies into all of your application pods. And when you've done that, that's what gives you the service mesh, this interconnected mesh of services that you can control independently. Now, we only looked at one aspect of that control, which was with the virtual service applying timeouts and retries, but there are a whole set of features that we're going to explore in the rest of the course, covering traffic management for routing and load balancing, security for identity, authentication and authorization, and observability. All that traffic goes through the mesh can record metrics on everything that happens, and that powers a bunch of dashboards that show you the overall health of your applications. I talked briefly about the Istio release cycle, and it's important to know that Istio is a production-ready system. It was developed for very high load at Lyft, and it's in use right now in eBay, IBM Watson, and PubNub. So there's some very big services that are depending on Istio and finding that it works really well for them. So in the next module, we're going to look at traffic management. We're going to see how we can use Istio for routing traffic between components and how that can power blue-green and canary deployments.
Давайте зробимо перерву, і після перерви вже домовимося, що будемо робити далі. Значить, зараз 11:12, а перерва до 11:17.
Recording stopped.
Окей, продовжуємо. Дивіться, питання до вас. Тут є вибір. Ми почали дивитися на Istio, і ми можемо на наступній півпарі ще подивитися деякі теми з цього курсу. Наприклад, це може бути більш такий, більше подивитися в ці віртуал-сервіси. Також вони казали, що вони використовують гейтвеї, тобто більш подивитися в ці віртуал-сервіси і гейтвеї. А далі подивитися на circuit breaker, як вони організовують circuit breaker. Ну, наприклад, і, можливо, якусь візуалізацію, яку може дати Istio по трафіку. Чи друга опція, ми можемо розпочати наступну тему, це меседжинг в мікросервісах. Яка вам опція подобається більше? Да, кажіть.
Ну, особисто мені, наприклад, було цікаво, щоб подивитися про circuit breaker і про gateway. Ну, якщо за мене казати.
Мені теж.
Да. Давайте сьогоднішню лекцію ось на Istio сфокусуємо тоді, бо це велика тема, ми тільки трошечки. Добре, тоді давайте тоді ось тут у нас є understanding, ось цей відосик. Так. Раз. Два. Так. Gateway. Ну, принаймні, ось ці три відео подивимося, а далі вирішимо, що ми можемо ще з цього подивитися. І circuit breaker. Тобто ось ці два останні відео. Окей? Тобто 3 перших і 2 ось цих.
Istio is the control
Чути зараз?
Так, чути.
plane for your application network, so you can use it to manage the traffic between your services without changing the services themselves. That opens the way to a lot of advanced patterns like canary deployments and circuit breakers, which are very difficult to do if you don't have a service mesh. Hey, how you doing? My name's Elton, and welcome to Managing Service Traffic, the next module in Pluralsight's Managing Apps on Kubernetes with Istio. This is going to be the longest module in the course because managing traffic is one of the core features of Istio, but we're going to keep it real with a scenario-focused approach, showing you what you can do with Istio as well as how you do it. So in this module, we're going to cover some really interesting deployment patterns with Istio. We're going to see how we can deploy new versions of microservices, but only make them available to certain users. That's called a dark launch. So my new software is running in my production cluster, but maybe only the test team have access to it. Then when the test team are happy and we're ready to roll out the deployment, we have a couple of options. One of the most popular is a blue-green deployment, which means we have 2 versions of our application running in the cluster, and using Istio, we can flip the switch and send all traffic to the new version of the application. Now that's an all-or-nothing approach, and a slightly more sophisticated version is a canary deployment. In a canary deployment, we have both versions of the application running, and we're using Istio to shift traffic between them. So when we first deploy version 2, we're going to send most of the traffic to version 1 until we gain confidence that version 2 is working correctly. And then we can do a staged rollout, gradually increasing the amount of traffic to version 2 until ultimately we're sending all the traffic to version 2, and that's our completed rollout. And the last traffic management pattern that we're going to cover in this module is to do with the health of your application. We can use Istio to implement a circuit breaker. Now in this deployment, I have my product page component, and I have 2 instances of my details microservice. Now they're replicas of exactly the same container, I'm just running them at scale. Now Istio will load balance any of the requests from the product page among all the instances of that details component. But with the circuit breaker in place, if one of those instances fails, then Istio takes it out of the load balance pool, so no more traffic gets sent to it. And that could give that instance time to recover, so it could become healthy again, and then it can receive more traffic. All these scenarios are enabled by a couple of custom Istio resources. Now, we've already looked at the virtual service in the previous module, introducing Istio. We're going to dig a lot more deeply into it in this module, and we'll also introduce the destination rule. Between those two components, that's how you configure traffic shaping in Istio to manage where requests get sent and what the behavior is if those requests fail. So just to recap on the virtual service, it's an Istio component that takes the place of a Kubernetes service. So when a component is running in Istio and it looks up a host name, like the reviews domain in this instance, it will use the routing rules for this virtual service. In this case, that's HTTP traffic, and it's going to be routed to one of the pods in the reviews Kubernetes service. And that's all functionality that we've already seen. But what we're going to introduce now is this idea of a subset, which is where the destination rule comes in. So in this example, any traffic going through the Istio proxy looking for the host called reviews will actually go to this subset v2. And that subset is defined in the destination rule, which is a separate Istio resource. Now in the destination rule, we specify the name of the host, and also we declare those subsets. And when you're running in Kubernetes, a subset is a selection of the pods within a Kubernetes service. So I can have a subset defined as v1, which will only use pods that have the label version equals v1. And similarly, my v2 subset will only pick pods that have the label version equals v2. Now those labels are really important. You can apply labels to pretty much any Kubernetes object, and they're used by Istio to identify the real targets for your network traffic. So that's going to be much clearer when we see this in a diagram. So I've got a couple of pods running here for my reviews service. Each pod has the same labels, the app equals reviews and the version equals v1. Now, if I deploy a new version of my application, I could have two new pods. They have the same application label. They're still called app equals reviews, but these have a new version label, version equals v2. In the Kubernetes world, I give network access to those pods by creating a service, and that service has a selector, which is how it identifies the pods that are ultimately going to get the traffic. Now, in this case, my selector is going to use the label app equals reviews, which all of those pods have. Version 1 and version 2 have that label. So my Kubernetes service is going to load balance traffic across all those 4 pods. That may or may not be what I want, because clients looking for the reviews host are going to either get a v2 response or a v1 response, but that's how the Kubernetes setup is. But the Istio setup gives me much finer control.
Я зупинюсь. Тут трошечки, мені здається, зараз трошечки неправдива інформація. В якому плані? Kubernetes вміє робити деплоймент, і по дефолтна стратегія, яка використовується, це такий rolling update. Тобто він спочатку, наприклад, тобто 2 інстанси, версія 1 і версія 1. Він спочатку прибере один інстанс і замінить його версією 2. Тобто, да, в нас виходить так, що будуть окремо одночасно V1, V2, а потім він забере ось цей V1 і замість нього дасть другий V2. Тобто, дійсно, в момент такі переходу, rolling update, ми можемо отримати 2 версії робочими. Також, ми це не розбирали, але це можливо, ось цей blue-green чи canary Kubernetes теж вміє. Тобто, для мене ось зараз це можна робити так чи інакше. Тобто це не означає, що Kubernetes з коробки не вміють це робити. Просто вони роблять це там якось по-іншому. Тобто це не означає, що це істина в останній інстанції. Тобто можна іншими засобами плюс-мінус того самого досягти.
So I can create a virtual service, and any components running with the Istio proxy will use my virtual service when they try and send traffic to the host called reviews. Now, what Istio does is it uses the Kubernetes service to find the IP addresses of all the pods. So the virtual service doesn't route any traffic through the Kubernetes service, but it just uses it to get the list of endpoints where the traffic could go. So without any additional rules, the virtual service in Istio will use all the same pods that the service uses in Kubernetes. But if I add a specific subset in my virtual service, then it uses the targets identified in the destination rule. So in this case, any services that are using the Istio proxy, when they look for the host called reviews, the request comes into the virtual service, which uses the destination rule to identify that subset v2, so the traffic gets load balanced between the two pods that have the version equals v2 label. So the destination rule is just a way of segregating traffic to direct it to a specific set of pods. It may look complicated, but when you work with it in practice, it's actually pretty straightforward, and we'll see that in a demo next. In this demo, we're going to use virtual services and destination rules in Istio to do a dark launch for a new component in our application. We'll use Istio to enable end-user routing, so different users of the application get different behavior, and that means our test users can see the new feature in action, while everybody else continues to see the original version of the application. And when we have that in place, we'll extend it to include some fault scenarios, so the test user can validate that the application works correctly, even if the service doesn't respond as expected. Okay, so this is demo 1 for this module, and all the content that I'm showing you is in the M3 folder. Every demo is documented with the README file, and then all the YAML files are there for the Istio deployments. So first of all, I need to make sure I've got my application running. I'm using Kubernetes on Docker Desktop, and one of the great features of Docker Desktop is that in the settings, I can go to Kubernetes and click Reset Kubernetes Cluster, and that tears down my cluster to a completely fresh Kubernetes instance, which is great if you're playing with different versions of Istio or different versions of your application, and you just want to reset everything. So I've reset my cluster, and I'll start by deploying Istio and my book info application from the manifests that are in this setup folder. Okay, that looks good. I'll just check my application pods are all running. So all my components are on v1, and every pod has 2 containers. So that's my application container plus the Istio proxy. So that all looks good. So now I'm going to deploy a new version of the review service. So this is a standard Kubernetes deployment. There's nothing Istio specific in here. It's just a deployment giving me one replica with the new version of the image. And the pods are going to have 2 labels, one saying the app is reviews and the other saying the version is v2. Okay, so let's go and deploy this. That looks good. And if I check out the pods, I've got 2 pods, one for the v1 component and one for the v2 component. Now, if I look at the Kubernetes service, so this isn't the Istio virtual service, this is the Kubernetes service, then I see the selector just has app equals reviews. So there are 2 endpoints for the Kubernetes service, one for each of my pods. So even though they have different version labels, the selector is only using the app label. Both of those endpoints are in the Kubernetes service, which means unless I shape the traffic using Istio, it's going to get load balance between version 1 and version 2. So I'll see that if I open my application. This is the version 1 reviews component that just has the text review. If I refresh, I get version 2, which has this star rating. And as I refresh through, it's getting load balance between my version 1 and version 2 service. But that isn't what I wanted. I wanted to do a dark launch so only my test users see that version 2 component with the star rating. And that's where Istio comes in. So in my demo folder here, I've got a YAML file which describes that dark launch in terms of an Istio virtual service and a destination rule. So my destination rule here says I've got 2 subsets. Any pods with the label version equals v1 go in the v1 subset. Any pods with the label version equals v2 go in the v2 subset. And then I've got a virtual service. And the virtual service is for the hostname reviews. So any components that are running through Istio that have the Istio proxy, when they make a request for the reviews host, they're going to come into the Istio virtual service rather than the Kubernetes service. So these rules will apply. And there are 2 rules in here. One is an explicit match that says look inside the HTTP headers for the request. If there's a header with the key end user and the exact value tester, then this route will apply, which will send that traffic to the v2 subset. And if there's no match, so if there isn't an HTTP header called end user, or if the end user has a different value from tester, then send the traffic to v1. So when I deploy this, everyone will see the version 1 of the reviews component, unless you're a signed in user with the name tester, in which case you'll see version 2. Now, normally you wouldn't have an HTTP header with a username, but there are other ways of doing matches with cookies or with JSON Web Tokens. So you can get the same effect using different authentication methods. So when I go and apply this, clear this down. So I'm going to apply my rules for the tester. And I'm going to check my virtual service. So those rules are in place. So I've got my match on my end user header and I've got my default route for V1 and I haven't deployed any other Kubernetes components. So my pods are still exactly the same. My Kubernetes service is exactly the same. Those applications are still running, but now the routing rules are being configured through Istio. So if I go back to my browser and if I refresh, because I'm not signed in, my requests from this application don't have a header with end user. So I always see version 1 of the reviews component, which has the text review, but without the star rating. If I sign in now as me, and there are no user accounts in this app, by the way, so if you're trying it yourself, you can just put anything in without a password. If I click sign in, I'm not the test user, so I still get version 1. But if I sign out and then sign back in as the tester, this is going to match the routing rules in the virtual service, and this user will always get version 2. So this is a dark launch because the new version of the component is live. This could be our production cluster, but only specific users are able to see this. So this is great because you don't have to use feature flags or some third-party service to get user-specific features. And because this is happening at the network layer, you can do some more interesting stuff too. So if I'm a test user, I want to make sure that the functionality is correct, but I might also want to make sure that the web component behaves correctly if the new microservice fails. And I can do that with Istio too because it lets you inject faults into the communication between your components. So if I open up this YAML file, this is a change to the configuration to my virtual service. So the default route is still for version 1. So everyone who is not signed in or signed in with a name other than tester will get the version 1 component. But the test user will get the version 2 component, and every single call to the version 2 component will have a 2.5-second delay applied by Istio. So this is a really good way to test out that the application behaves correctly if a call to a microservice times out or takes longer than expected. So I deploy this in the same way as all my other deployments. So I apply my YAML file, and now if I browse back to my application, I'm still signed in as the tester. If I click refresh here, you'll see it takes a couple of seconds before the page returns. And again, every single time I do this, the call to the reviews component has got that network delay, and I'm just checking that my web page doesn't time out and that I still get a useful response. If I sign out as the tester, then every time I refresh, I get an almost immediate response because it's not adding that network delay. And there are other types of fault that Istio can inject. So I can also inject an HTTP error, this YAML file here. Again, it's just a change to the virtual service. I'm leaving my default route exactly the same, but I've changed the fault condition here. So 50% of calls will get a 503 response for the end user whose name is tester. So I can deploy this and then check my application behaves correctly if my new service fails. So back to my application, I'm not signed in. So when I refresh, the app is still working correctly. If I sign in as the tester again, that calls work correctly. If I refresh, then some of these network calls are getting a 503 from Istio and others are going through to my component. So I can use Istio to delay or break the communication to components without having to change my applications themselves. And of course, what I'm doing here is defining these rules in a YAML file and applying them with kubectl. So I could do that as part of a CI/CD process and have chaos testing as part of my release, even in the production environment, because I'm making sure that only specific users get this behavior.
Тут я б хотіла зупинитися і трошки поговорити. Він підняв дуже цікаві теми. Зараз виговорюся. Значить, дивіться, він казав про те, що ми можемо відкривати фічу тільки для тестових користувачів. А також він казав, що те, що він показує, є альтернативою до використання third-party систем для фічі-флагінг. Питання до вас. Чи стикалися ви колись з цією темою фічі-флекс? Щоб ми її розкрили зараз. У вас є емоційні реакції, дайте, можливо, там щось, там плюсик, мінусик, там смайлик в зворотньому боці. Коли ми релізимо щось, коли ми релізимо систему, і нова версія є видною тільки якійсь частині користувачів. чи хтось взагалі стикався з цією проблематикою і дивився на це. Тобто ми релізимо нову фічу, не систему, а нову фічу. І нова фіча є видимою тільки там якомусь сабсету користувачів.
Я з таким не стикався.
Значить, дивіться, тут є така ще штука. Я зараз покажу, можливо, тут зараз погуглимо разом, щоб були. Feature toggles and feature flags. Є ідея. Ідея в тому, а як ми це можемо організувати? Тобто проблематика зрозуміла. Ми випускаємо нову фічу, але не хочемо її показувати відразу всім. Ми хочемо її показати маленькому сабсету користувачів, а потім, якщо все гаразд, то відкрито на всіх. Він показував, там, наприклад, для тестових користувачів. Але це можуть бути не обов'язково тестові користувачі, це можуть бути, наприклад, в нашій системі є багато кастомерів, і тільки на одного якогось кастомера ми відкриваємо цю фічу. Зазвичай такі речі робляться за допомогою third-party системи, яка менеджить фічі-флаги. І зазвичай ми в цій системі, один з прикладів такої системи – це Launch Darkly, зараз покажу. Так, можливо, якісь, що була якась картинка. От ми кажемо, ми випускаємо нову фічу і кажемо, кому вона може бути доступна. Тобто, якимось чином ми вміємо тобто ми скажемо на базі якісь атрибути реквесту, там, наприклад, це користувач від якогось кастомера, чи це там ще якісь там атрибути користувача, і на базі цих речей ми зможемо вибрати ті реквести, для яких ми цю фічу відкриємо. А з точки зору, як і наш фронтик, тобто в нашому фронтику має ця фіча бути вказаним, що там певні сторінки, вони відносяться до цієї фічі. І тоді кожен раз, тобто, по суті, тут у фронтику треба писати, якщо фічі-флаг включений, то ми показуємо. Якщо фічі-флаг не включений, то ми не показуємо. А от чи включений фічі-флаг, чи не включений, ось саме ці треті системи, third-party системи і вирішують. Тобто це зазвичай такий підхід до фічі-флагів. Питання, чому нам треба фічі-флаги? Я зараз вам дам такий кейс. Якщо ми кажемо про ідеальний світ, то в ідеальному світі є така штука, як continuous deployment. Насправді, це треба дуже інвестувати, щоб досягти цього continuous deployment. Але ідея в тому, що ми деплоїмо код, тобто ми розробили код, ми перевірили код, ми його мерджимо і зразу деплоїмо на продакшн. Ми знаємо, ми перевірили, ми тестували, він хороший, він гарний. Тобто ми не чекаємо кінця спринту, чи ми не чекаємо ще якогось, наприклад, деплоїмося раз в місяць, тобто ми не чекаємо точки деплою, ми деплоїмося постійно. Але питання, При такому підході в нас може бути фіча half done. Тобто ми не робимо, тобто при такому підході ми робимо там маленькі задачі, і фіча буде зроблено, коли багато цих маленьких задач буде зроблено. І ці маленькі задачки з боку фронтіку, і з боку беку робляться. І тобто, наприклад, там фронтові сторінки ми теж робимо, там деплоїмо, але питання, невже, тобто тоді ми користувачу даємо, не готову фічу. Так от, коли ми використовуємо continuous deployment, то, по суті, в нас моменти деплою та релізу, вони рознесені. Тобто деплоїмося ми постійно, але ми все ще релізимося по певному скеділу. Тому що реліз – це певна комунікація. І от реліз – це буде відкриття фічів. Тобто, окей, ми відкрили фічі, ми інформували юзерів про те, що в нас там нові фічі доступні. Тобто це use case для використання, чому нам треба фічі-флаги, один з use case'ів насправді. Один з use case'ів, коли нам можуть бути треба фічі-флаги. Багато говорили, чи є питання?
Немає. Все зрозуміло.
І ще один момент, він дуже класний, теж тут підняв. Він казав про тестування фолтів. Тобто, коли, пам'ятаєте, тут були рули, і ми для тестерів організували, що 50% реквестів до мікросервісу, вони будуть падати. Насправді, дуже класна штука, бо от ми з вами кажемо про це все, ось там про тайм-аути, ретраї, circuit-брейкери, а тестувати як? Тобто це все гарно, говорити можна класно, а тестувати як? Це все довести треба, що воно працює. І отут великий знак питання, бо тут, як ми це будемо робити, це непросто. А в мене там трошечки в кінці лекції є трошечки слайдів, як ми можемо робити саме таке fault tolerance тестування, але дійсно ідея в тому, що ми маємо інжектити фолти. І він показав, як... І там можна, насправді, різні системи використовувати, які будуть інжектити фолти, і на різних... знову ж таки, можна робити там на рівні CI. Там ви докери підняли, там в докери заінжектили фолти, тобто якось дуже лімітовано це перевірили. Можна робити це на full scale, тобто піднімати взагалі окремий інстанс системи і робити, тобто якийсь агент, він казав chaos testing, таке хаос. Тобто в будь-якому місці системи виникає фолт. І як система на то буде реагувати? І ось цей Istio, він насправді теж його можна використати, щоб зробити такий fault tolerance testing. Як варіант, наприклад, ми fault tolerance testing, думаю, слід робити на окремому деплойменті. Тобто окремий деплоймент системи ми підняли з Istio, заінжектили ці фолти, і, в принципі, можемо подивитися на те, як система себе веде. Там і якимось... але, знову ж таки, це окрема QA-задача, окреме планування, це я зараз просто на рівні ідей кажу. Зупиняюся. Чи є питання ось по fault tolerance? По тестингу цьому, по fault tolerance тестингу. Добре, значить, тепер Gateway. Давайте про Gateway послухаємо.
In that demo, we saw how to use Istio to do a dark launch of a new feature of our application. We deployed a new version of the reviews component, and we configured Istio so the test user sees the new version of the component, but every other user sees the original v1 component. And we did that with two Istio resources, the destination rule and the virtual service. The destination rule here just defines the available subsets. So the subset v1 selects pods that have the v1 version label, and the subset v2 selects pods with the v2 version label. And then in the virtual service, there's the routing rule that says if the HTTP request has a header called end user and the value of that header is tester, then the request gets routed to the v2 subset. And we saw how to extend that to include some fault injection into the communication between the web page and the reviews component. In this case, when the test user is logged in, then every single call to the review service has a 2.5-second delay applied so the user can test the web page functions correctly. And here we can see the default route that says if there is no match on the HTTP header, which means the user isn't logged in or is logged in with a different username from tester, then all those requests go to v1. And the last thing we saw was a variation of that injected an HTTP fault into 50% of the calls. So this is really powerful stuff because it's happening at the network layer. So when we're injecting an HTTP fault, the web page component actually gets an HTTP 503 response. So it's a genuine network response, but it's come from Istio instead of the service. And this kind of dark launch is a really nice way to gain confidence about a new feature, that it works correctly, and when it doesn't work correctly, the rest of the application still functions. So a dark launch is a really nice way to get confidence about an application change, and when you're ready to release that to all your users, Istio gives you a couple of powerful deployment options. And the first one we'll look at is blue-green deployment. So with blue-green deployment, I can have two versions of my application running, and in this case, the live site, bookinfo.com, is going to my v1 product page, and I've got a test site that's using the v2 product page. So actually, both of these versions are live on different domain names, and maybe the test domain isn't publicly available. I've got some set up in my cluster, so that URL is only available from within my organization. Now, with a blue-green deployment, Istio effectively gives you a switch that you can flip. So when you're ready to go live with v2, you flip the switch, and now the live website at bookinfo.com is being served by the v2 deployment, and my test website is still available at my v1 deployment. Both those versions are still up and running, so if I have a problem with the new deployment, I can flip the switch back again and send all my live users back to version 1. Now in this example, I'm not just using Istio to change the routing between components in my application, I'm using Istio to route external traffic. So the traffic management rules that I apply, they're still within the virtual service and the destination rule resources, but because I want my rules applied to external traffic, I need to have this gateway component so that Istio receives the incoming traffic and then applies those rules to send the end user to my product page application. So there's a little bit more going on in this kind of configuration. So I've still got a destination rule with my two subsets set up that are picking pods based on the labels that they have applied. But because this virtual service is listening for external traffic, it has the full domain name as the host. So external traffic that's coming into my cluster for the bookinfo.com site is going to get served by my v1 subset. So that traffic will go to one of the pods that have the version v1 label applied. Now I have a separate virtual service with the host name test.bookinfo.com living in the same cluster, and that's using my subset v2. So when traffic comes into the cluster, browsing to test.bookinfo.com, that traffic's going to get served by one of the v2 pods. And because this is external traffic, in order to have the Istio rules applied, I need to have a gateway listening for incoming requests. And I can have a gateway that listens for traffic on any domain name, and depending on the request that comes in, it'll direct it to one of the virtual services, which will go through the subset and ultimately to one of my pods. So this all looks pretty complicated, but actually what it means is when an end user browses to bookinfo.com, the request comes into my Istio gateway, which directs it to my virtual service, which is configured to use subset v1, so their response is going to get served by one of my v1 pods. And if a different user browses to test.bookinfo.com, it still comes into the same gateway, but the gateway directs that traffic to my test virtual service, which is using subset v2, so that user will get a response from one of my v2 pods. So this is the basic setup that we need to have a blue-green deployment. In our blue-green deployment, the key part of the configuration is which subset each virtual service uses. So right now, the live site is being served by subset v1. When I'm ready to do my deployment, I flip the switch, and now the live site is using v2, but the previous version of the application is still running and it's available on the test domain. So once I've flipped that switch and done my deployment, now when my user browses to bookinfo.com, it comes into the gateway, the host hasn't changed, so it goes to the same virtual service, but now this virtual service is using the v2 subset, so their response is going to come from one of my v2 pods. So it's still the virtual service and the destination rule that's configuring the traffic routing, but because this is external traffic coming in, I need that gateway to receive the traffic and then link it to my virtual services. And we'll see how all this looks in the demo next. In this demo,
Я говорила і з виключним мікрофоном говорила. Я кажу, що до кінця пари ми встигнемо подивитися ось це демо про гейтвеї. І пара закінчиться. Але я не хочу цю тему переносити на наступний раз, тому я продовжу запис. В кого немає часу, ви можете відключатися. А хто може, будь ласка, залишайтеся. Але я це запишу все. І на відео я ще запишу ось ці дві теми. Це circuit-брейкери, ось ці два відео пояснення та демо до circuit-брейкерів.
We're going to see how a blue-green deployment looks with Istio. We're going to run two versions of our Bookinfo application on live and test domain names, and we'll use Istio to switch the test version and make it live, and we'll also see how we can switch back again. Okay, so these are the demo 2 docs. I've already done step 0 and deployed version 1 of my application, and we'll see the pods are up and running. So to start with, I'm going to do a deployment that has two versions of my application available from different host names. So we already have a gateway running because that was part of the original deployment, and that's listening for HTTP traffic on port 80 for any host name. So I don't need to have a new gateway, I can use the existing one. And when I do my deployment, I've got everything I need in this single YAML file. So to start with, I've got the deployment for version 2 of my product page application. And just like all the other components, the pods are going to have two labels, the app name, which is product page, and the version, which is v2. So when this deploys, I'll have one pod with my v2 product page and my existing pod with my v1 product page. I've also got a destination rule in here, and this is the same kind of setup that we've seen already for the internal service, the reviews component. So where the host name is product page, there are two subsets. V1 is going to select the pods with the v1 version label, and the v2 subset is going to find the pods with the v2 version label. I've got an update for my existing Bookinfo virtual service. So this is where I'm specifying the host name. Now I'm running this locally rather than through a global DNS, so I'm just using a .local domain name. This virtual service is going to bind to my Bookinfo gateway, so when traffic comes into my Bookinfo gateway, the gateway will pick up the host from the HTTP request, and if the host is bookinfo.local, then it will come into this virtual service, and this virtual service is using subset v1. And I've also got a new virtual service to make version 2 of my application available on a different domain name. So this virtual service binds to the same gateway because that gateway is listening on any host, and traffic will get sent to this virtual service if the request is for test.bookinfo.local. And so if I browse to that domain name, the traffic comes into this virtual service and it's going to use the v2 subset. So bookinfo.local will be v1, the current version, and test.bookinfo.local will be v2, and that's my new version. Okay. So let's clear the screen down and we deploy this in the usual way. So that's my new deployment, my new destination rule, a change to my existing Bookinfo virtual service, and my new Bookinfo test virtual service. So all those changes come in one deployment. Let's just check that everything is running. So for my product page, I've got one v1 pod and one v2 pod. The virtual service for my live site is using subset v1 and it's listening on the host bookinfo.local, and the virtual service for my test site, that's using subset v2 and it's listening for the host test.bookinfo.local. Now those aren't real domains, so I've added them to my host file. So on Windows, that's in C Windows System32 drivers etc. hosts, and they're just directing to my local machine because everything's running in my local cluster. You can do the same thing on Linux or Mac in your etc host file. So now if I browse to my v1 site, I see the same application. Let's zoom in a little bit. This is my version 1 app. Nothing's changed since my original deployment. I'm still using version 1 of my reviews component, but now this is being served with a real domain name, so it's going through the gateway and into the virtual service, and the destination rules get applied. So if I browse to test.bookinfo instead, then I see my newly rebranded v2 version freshly back from the design consultancy, and this looks much better. Okay. So everything's in place for my blue-green deployment, and if I want to switch and make my test site live, all I need to do is apply this YAML file, which changes the subsets for each of my virtual services. So now my virtual service for my live site, bookinfo.local, is now pointing to subset v2. The virtual service for my test site, test.bookinfo.local, is pointing to v1. So I've flipped the subset for each of my virtual services. And again, the deployment is the standard kubectl apply. It just changes those virtual services, and if I look at the live virtual service, That's using subset v2, same host name, so now my live site's going to come into v2. I switch back and go to my live URL. I've flipped the deployment, so now my live site is v2 with the fancy new design, and if I browse back to my test site, that's now v1. So I haven't changed any of my Kubernetes definitions, my pods, my services, all that's the same. All I did to do my blue-green deployment is to flip the subsets in each of my virtual services. And if I find when I've done my deployment that the CEO comes knocking on my door saying that she doesn't particularly like the redesign, the original version of my app is still up and running with the same scale that I had previously, so I can switch back to v1 just by flipping the subsets again. So in this deployment manifest, all I'm doing is putting my virtual service for bookinfo.local, the live site back to v1, and the test site back to v2, so we can go back to the test phase and maybe refine our design a little bit. So I'll apply my live back to test, go and check my sites, and my live site is usable again, and my test site has Comic Sans. Now, if you don't want to tie your deployments down to specific versions, then it's just about how you name your subsets. So if I wanted to, I could name my subsets blue and green, and that's where the term blue-green deployment came from. And then your deployment is to switch the live site from the blue subset to the green subset. It's just a question of terminology, really, and it's the same simple process to flip between the two.
До речі, треба подивитися, як робиться, бо Kubernetes теж вміє робити blue-green deployment. Треба подивитися, як саме, для бажаючих це буде таке домашнє завдання, подивитися, як blue-green deployment можна в Kubernetes зробити. Окей, розглядаємо дві наступні теми. Це, ці два відосики.
So in that demo, we saw how to do canary deployments, to have two versions of our application live, and to use Istio to shift the weighting of the traffic between those two versions. And again, we're configuring that with the same type of Istio resources. So that's all done in the virtual service, where for a particular route, I can have multiple destinations. So on the left-hand side here, I've got a 70-30 split. The majority of traffic is going to V1, and 30% of traffic will go to V2.
Поясню, він якось робить рекеп ось цього canary деплойменту. Canary деплоймент – це ми певний відсоток трафіку пускаємо чи на нову версію, чи на попередню версію. Ось це canary deployment. Тобто, якщо в Blue-Green ми повністю переключалися чи на один, чи на другий, то в canary ми частинку трафіку пускаємо. Значить, ми не дивилися ось ці відосики з canary deployment. Ось тут з цих сторінок ви бачите, що ми weight визначаємо. Продовжуємо.
And on the right-hand side there, this is way down in my deployment cycle, where only 5% of traffic is going to V1 and the other 95% is going to V2. Now, we also saw in that demo that during the canary rollout, users can have a kind of strange experience, where sometimes they see V1, sometimes they see V2, because the weightings are random. And we saw how to fix that using a cookie. So there's some application work here to make sure that you set the cookie, but as long as the cookie's there, you can do a staged rollout with a kind of sticky session experience. So as soon as users have seen V2, the request that comes in will have that cookie, product page equals V2, that matches this first rule in my virtual service definition, so those users will always get sent to subset V2. Any other users that don't have that match, they'll fall into the default route, which in this example has my 70-30 split. So I get a canary deployment, I can do a staged rollout, I can gain confidence in my new version, but I can still support a good user experience. So the last thing we're going to cover in this module is a different type of scenario that uses the same features of Istio. But this time we're going to use those features to increase the reliability of our application. So in this example, I've got a new version of my details component and I'm running that at scale. So in Kubernetes, I'll have two replicas, two pods running identical software, and Istio is going to load balance requests between those two pods. Now, if the application starts to fail in one of those pods, by default, Istio is going to keep sending traffic to it. And that's a problem for two reasons. Firstly, because this instance may stay unhealthy now, but Istio is going to keep sending traffic to it, so it will keep getting errors. And the second part of this problem is, if I've configured Istio to automatically retry when it gets errors, and we saw how to do that in the module called Introducing Istio, then what I'm going to end up doing is sending even more traffic to this failing component, and that can amplify the problem. And Istio lets us fix this using a circuit breaker pattern. And what the circuit breaker does is it monitors the behavior of all of the instances that are in that load balance group. And if one of them starts to fail, it takes it out of the group. So it doesn't send traffic to it anymore. And you can configure how long to watch for errors, how many errors trip the circuit breaker, and how long to keep failures out of the group. So if that instance has failed temporarily and a period of calm allows it to reset, then the circuit breaker pattern means when it comes back into the load balance pool, it could be working correctly, and this will keep your app running even during transient failures. Now, even though this is a completely different type of traffic management scenario, it's still traffic management, so you still use virtual services and destination rules inside Istio to configure this. This is internal communication between my product page service and my details service. So there's no gateway involved because the traffic's being routed through my Istio proxies, so I just need to set up my virtual service and my destination rule. And this is how that looks. So I've got one pod running version 1 of my details component, and I've deployed a new version, version 2, which is running at scale across 3 pods.
Мені здається, я не поставила запис. Пам-пам-пам-пам-пам-пам-пам. Так. Я другу половину пари не записала. Пам-пам-пам-пам-пам-пам-пам. Да, окей. Значить, ми зараз відео додивимося, а потім я запишу. Я вибачаюсь, я була неуважна, я зараз тільки звернула увагу на цю штуку. Я запишу. Те, що ми на другій половині пари слухали, я запишу.
Now, if I want to send all traffic to version 2 of my component, I can have a virtual service where the host is details, configured to use the subset v2, which is using that label to send traffic among those 3 pods. Now, with this configuration, client requests get load balanced between those 3 pods. So Istio will share the load between all those pods. And if the application in one of those pods starts to fail, Istio is going to carry on sending traffic to it because it's still part of the load balance group. Now, to apply the circuit breaker, I add a traffic policy to my destination rule, and the traffic policy sets up outlier detection. Now, the outlier detection is just telling Istio to watch all the endpoints in the load balance group and make sure they're still behaving themselves. So in this case, the configuration is saying that if any one of those endpoints has 2 consecutive errors within a 1-minute period, then it's going to get ejected from the load balance group for 5 minutes. So if this pod at the top here has 2 errors in a row, then it gets taken out of the group and it won't receive any more traffic for the next 5 minutes. And that's the circuit breaker pattern. So we're telling Istio to monitor all the endpoints in the load balance group to find any outliers that start behaving badly, and will eject them from the group for a certain period of time. After that, they come back into the group and they'll start receiving traffic, but they're still being monitored. So if they fail again, they'll be ejected again. And we'll see how that looks in the demo coming next. In this demo, we're going to look at the circuit breaker pattern with Istio. I'm going to deploy a new update to one of my services with multiple instances, several of which are failing. And we'll see how Istio keeps on routing traffic to the failing instances until we deploy an update with outlier detection, and then the failing instances get taken out of the load balancer and the app just starts working again. So this is demo 4. I've already deployed the prerequisites. So if I look at my pods, I've got version 1 of my Bookinfo app is up and running, and each of the pods has 2 containers, an app container and the Istio proxy. Okay, so what I'm going to do first of all is I'm going to deploy a new version of the details service, which is the component that shows you the book details from the homepage. So this deployment is using a new image, and this application is set to be unhealthy. And this feature flag here says that when the application starts up, there's a 50% chance it will go immediately into an unhealthy mode, and it will return errors to every single call, and it will stay that way for the duration of the container. Now I'm deploying 4 replicas, so I should have 4 pods. 2 of them should immediately go unhealthy, and 2 of them should stay healthy. So in my load balancing set, I'm going to have some unhealthy instances. Now I've also got a destination rule here, which is the same thing that we've seen several times. So the host name is details. This is the details microservice. I've got 2 subsets. The V1 subset is going to pick pods that have the V1 label, and the V2 subset will pick pods that have the V2 label. I've also got a virtual service here, which is picking the V2 subset. All the traffic that comes from an Istio-enabled pod looking for the details host is going to come and route through to the V2 subset. Okay, so to start with, I'll deploy that. So I get my new deployment, a new destination rule, and a new virtual service. If I have a look at the actual service, this is the Kubernetes service, not the virtual service, then I'll see there are several endpoints in here, 5 in total. So that's the version 1 pod that's running and the 4 version 2 pods. So they're all part of the Kubernetes service because that's just selecting on the app name. So app equals details, and all the pods v1 and v2 match that. If I have a look at the virtual service in Istio, then I'm confirming here that the subset is v2. And if I look at the destination rule, that shows me that my v2 subset is picking those pods that have the v2 label. Okay, so if I browse to my homepage now and refresh a few times, it's the details microservice that's providing the data for this panel on the left. And what I'll see is as I refresh, sometimes I'm going to hit one of those services that's failing. So of the 4 pods that match the routing rule for subset v2, 2 of them should be unhealthy and 2 of them should be healthy. And the unhealthy ones stay in the load balancing groups. So even though they're constantly returning HTTP errors, they stay available for new client requests. Okay, so I can check that by looking at the logs for some of those pods. So this is going to get me the logs for any of the v2 details pods. And what I'll see here is that some of these are returning unhealthy and they're returning 500s. Sometimes they return a 503. And then when I get a response back from the homepage, just hit a healthy pod that's returning a 200. Okay, so now to fix this, I don't need to make any changes to my application. I can apply the circuit breaker, which is just a change to the destination rule. So the virtual service stays the same and sends all the traffic to the v2 subset. But within the v2 subset, I've got this traffic policy applied. It's the traffic policy that contains the outlier detection. So this logic's actually happening on the client side. So inside each proxy that's going to make calls to the details service, it's doing the outlier detection and checking on all the available endpoints. So these rules here say watch all the endpoints over an interval of 1 minute. If any of those endpoints return 2 or more consecutive errors within that 1 minute window, then they get ejected from the load balancing group and they won't get any more requests sent to them for the next 5 minutes. Now that max ejection percent there says how many endpoints am I allowed to eject from the group, and I'm saying 100%. So if all the pods fail, then they all get evicted and there's nowhere to route any traffic. Now these parameters here are the things you're going to tune for each of your services because they'll all have different values here. But the pattern is the same. Watch all the endpoints. If any of them start behaving badly, they get ejected from the group. Now, it's important to remember that the checking happens on each client. So each proxy container is doing its own outlier detection. And that's necessary because you might find that a particular service is always failing for one particular client. So you don't want a global policy that evicts that service from the load balancer for everybody because it could be working fine for other clients. And that's why Istio implements this as a destination rule, which gets enacted in the proxies. So each proxy has its own load balancing group, which contains the endpoints that it's going to use. Okay, so the deployment here is the same as always with a kubectl apply. And the only thing that's changed is my destination rule. So I can just confirm that. So I've got my traffic policy in there within the v2 subset. You can apply traffic policies across the whole destination rule or individual ones for different subsets. My v1 subset doesn't have any policy, so there's no circuit breaker there, but I'm only using the v2 subset and that I have my circuit breaker in. Okay, so now if I go back to my application, so what we're seeing here is already those badly behaving endpoints have got ejected from the load balancing group for my client because they're returning failures. So as the user, I don't see any more error messages. So what's happening here is I have 4 pods that are running version 2 of my details application. 2 of them are unhealthy and they're not receiving any traffic anymore. So the outlier detection has found those 2 instances. It's not sending them traffic. So now the application has healed itself. And if I were to wait 5 minutes and retry again, then traffic would start flowing into those services. They would send unhealthy responses again, and they'd be removed from the group. But if this was a real deployment, then those errors would happen if the endpoint got overloaded. So when the endpoint gets removed from the group, it doesn't receive any more traffic. And that period where it's not getting any client requests is hopefully enough time for it to clear down whatever the problem is. So when it's added back to the group, it's returned to normal service.
Ну, в принципі, все. Ми що хотіли, те подивилися. Значить, ми подивилися ось Managing Traffic. І це з Virtual Service, це з Gateway, і це з Circuit Breaker'ами. І на цьому тему Istio ми закінчуємо. Чи є питання? Тоді всім дякую і побачимося через тиждень.